This perspective is a panoramic view of the four elements of the transceiver. First element is the computer and the computer screen in the background, and then in the foreground are the three RF and DC modules that comprise the transceiver. We'll discuss each one separately. So I'll move in here and take a view of the computer screen on which the software, the GNU radio open source DSP software is running. You can see at the top of the screen the receive pen adapter. The receiver is in the receive mode. And I'll move the camera just a little bit and you can start to make out some of the details of the controls. These are rather ordinary transceiver controls. Receiver bandwidth, the RIT, mode selection, that sort of thing, audio volume and whatnot. And at the very bottom is the transmit and receive selector, and the mouse cursor is sitting on it. So while the transceiver is in the receive mode at the moment, if I were to select that bar, it would switch the software and the transceiver to the transmit mode. Then when I'm done transmitting, I just select that bar again and go back into the receive mode. So this free software is software you can program yourself and adjust to whatever communication needs you have. So backing out, looking at the three modules, the center module is the SDR, and it contains the EDIS B210 dual transceive SDR. And that transceive SDR actually covers a wide frequency range, 50 megahertz to 6 gigahertz. That forms the basis of the whole transceiver operation. To the left is a 10 gigahertz transverter from which I removed the transmitter part and just left the receiver for the purposes of this video. And on the right, in the mini ATX computer case, is what I call the peripheral, which provides all the DC control and switching functions for the complete rig. So let's zero in just a little bit on that center module, the SDR module. The big green board there is the EDIS B210. The large IC in the center is the FPGA. The smaller IC at the bottom, towards the bottom of this screen, close to the RF connector, is the analog devices analog tuner, and that's the one that covers from 50 megahertz up through 6 gigahertz. And near the top of the screen by the USB 3 connector, the little IC there is the FX3 data interface. Backing out just a little bit, you can see there's a lot of other circuitry in the SDR board. There are relays for transmit receive functions. There are small amplifiers on the right and on the left to boost the transmitter power up from the 1 milliwatt level to closer to 200 milliwatts. Filters for VHF stations like the FM broadcast band and such, and receive double protection on the receive relays to, especially when running high power, which isn't particularly relevant here, to prevent burnout of the RF components. You get a hint at the very bottom of the screen at all of the RF ports of the SDR are brought out to the front panel, which makes for easy configuration of home station use, remote use, or in this case, cross-band use. I'm going to move over and try to focus a little more clearly on this 10 gigahertz receiver. Again, the transverter has the transmitter submodule removed where that little coil of wire is, but you can see the wiring harness and relays. The golden object in the center is the microwave mixer, and I'll point to it with this pencil. This is the RF port and the filter that goes to the antenna if the unit were intact. This is the IF port coming out here going into the IF interdigital filter, And this is the LO port. It goes through an amplifier, the step recovery diode multiplier, the SRD multiplier, and then a relay control circuit. And like the SDR module over here, this has the RF ports coming out on the panel. There's one missing here because I disassembled it. And that is the 10 gigahertz receiver. Moving over here is the peripheral. It isn't very sexy, it's not RF, but it is the DC control circuit for the whole rig. Point here, you can see the keyer and keyer monitor speaker. Back here is the silver cube is the 10 megahertz double oven crystal oscillator to stabilize the synthesizer in this EDIS board. A lot of DC circuitry here, and then these two green boards. This is a layer of two green boards for sequencing the relays and for control of the latching relays in the microwave system. And you get a hint at the front panel here, the various keyer controls and master switches and such things. So I'd like to conclude with a summary statement. It's important to remember that with an SDR, you really need a lot of analog wraparound or analog interfaces to make for a real practical radio. So in the center you see all these relays and amplifiers and things contained in the box. I call that the RF interface. That makes this fancy, almost magical green board into a real practical and useful radio. The interface on the peripheral on the right is the DC interface, and that powers up all the various submodules and sequencing their operation and controlling their function. So with that, I want to thank you all for watching. I want to thank Michelle for her interest and support in this project. And I would certainly be willing to correspond with anybody who has further questions about this project. Thank you very much.